Okay, so Kai introduced myself, but I'll just add a few things in addition to what he said. So apart from completing my PhD in data visualization at Imperial, I also have 15 years of industry experience, but I do enterprise middleware as a part of my primary job role. But I also created Bars and Lines Limited, a company which basically commercializes the work that I did at Imperial myself and also a few others at the Data Science Institute, part of this. I was also previously the systems architect for that impressive data observatory Kai spoke of. I got some, yes, I got some photographs from the data observatory later in my presentation. If any of you would like to have a look at the data observatory, tours or anything like this, just let me know. So you can reach me via email. That's senaka@barsandlines.com. Or just through Kai or the group. If you're interested in having a look at Imperial State Observatory, just let me know so we can just organize something. Apart from that, so as systems architect, I was involved in basically running the entire observatory. The software that powers the data observatory is something I wrote. It was the basis of my PhD thesis as well. Apart from that, we also did like sorts of maintenance of the screens. It's a facility that involves 64 screens and 33 computers driving these screens. It's not that easy. It's like a cluster of computers. There's a lot of networking cables going on, and then so on and so forth. So all of that basically were things that I used to manage on behalf of the Data Science Institute at Imperial. I was also RA at the Data Science Institute before and after, sorry, like during and after my PhD. And then obviously I started Bars and Lines Limited, and I'm also a casual academic researcher according to Imperial's terms at the business school now. The Data Science Institute is actually part of the Imperial's business school and computing. So I completed my PhD. I was part of computing, but as things happen to be, now I'm doing academic research at the business school, but still affiliated with the Data Science Institute. But then comes WizExperts. So WizExperts is basically Bars and Lines, the company that I created, plus Imperial College. So Imperial has a good collection of, like a lot of researchers in the visualization space, but also related to the Data Science Institute, we got people in various other domains, professors from business, professors from geology. There are some experts in the medical space who work with the Data Science Institute. So all of them are not, well, not all of them, but some of them are part of WizExperts. Basically, the objective of WizExperts is to take what we did at Imperial and then kind of convert that into sort of, like approaches or, like tools that we could use broadly in the industry, or, like for general purpose use by anyone, literally. So WizExperts does collaborative research work. Like if you all were interested to do some collaborative research work with Imperial, you can do it through WizExperts. WizExperts also, we are trying to evolve it beyond Imperial. There are a few people who are at Imperial, but now at other universities, but also people from other universities who are also interested in being a part of WizExperts. So this is open to other people as well very soon. But we also do paid consulting as a part of WizExperts, and here more or less the folks, in my company, like Bars and Lines, basically are involved in this, and also we involve some researchers from Imperial as well in this consulting work. So we've done a few projects. If you want any details, again, I'm happy to explain it to you later on. Right. So I'll then get on with my talk today. So I'm talking about more or less about data literacy and the role of people who are building visualizations, because Based on what we used to do at Imperial, we understood that data literacy is not like literacy, like in terms of the way you speak. If you know a lot of words in English, you can speak very well. You can read, write, you can have a productive conversation. But data literacy, that is not solely that like something that the person who is reading sort of like a some sort of a chart can do on their own. Also, the person creating the data visualization needs to be considerate of many things. And then this talk basically points out that the role of the people creating the data visualization is more important than the people who are interpreting. Because if the person building like some sort of a chart or a set of charts or creating a data story or something like that, I've got examples of all of this here, does not pay attention to certain aspects, sometimes what they are trying to communicate is not clearly understood by the audience, and it can very easily happen. And even like the most how can I say it? Even though you have standards, even though you have best practices, people still make like the some sort of like very small maybe like problems with the way they present data, or they may have used the wrong color schemes and so on and so forth. So I got some examples from very well-known resources just to explain attention to detail being missed out and so on and so forth. So we can go into all of these things in the next few slides, but I'll start off explaining what is data literacy so that everybody is on the same page. So there are many interpretations of data literacy that we find today. If you do a Google search, of course, you'll get hundreds of them. But these are some of the very well-known definitions coming from the academia. So Kin and D'Ignazio in 2010 were some of the earliest to explain data literacy as the ability to understand or use and manage data. They actually called it science data and science data literacy, and then they were more talking about that as a part of a science. However, then we find Johnson in 2012 explaining this as a process to sort, filter vast quantities of information, requiring the amount, like the ability to search and how to filter and process, and and so on and so forth. So Johnson basically explained this as a process of, he was aligned more with big data, he basically said it is the ability to comprehend all of that complexity, the variation of data and the vast amounts of information that are available there, and the ability to process that and sort that, and filter that so that someone could understand it or interpret it in a meaningful way. And then comes Magnac and Gamma in 2013, explaining this as the ability to help people do things. So the ability to understand and use data effectively to, then go on to do things or interpret things in a meaningful way, and so on and so forth. And then lastly, Calzada Prado and Mazal in 2013 also explains this as the ability to access, interpret, critically assess, manage, handle, and ethically use data. So it explains like whatever you can do with data, according to them, relates to data literacy. So as you can see, data literacy is not just a very specific area. It's about being able to deal with all formats of data, the complexity of data, the ability to interpret something, the ability to explain something. You also need to sometimes, simplify what you want to say. So all of these things collectively means data literacy. And if you compare that to what is literally, if you something in like if you compare data literacy versus the literacy in maybe English, for example, right? You find around 600,000 words of English, according to the Oxford Press, that has been spoken over, like a long period of time, but we have about 1/3 of that currently in use as of now. But that does not mean someone needs to know all of that 200K words in order to be able to speak or read or write effectively. So there was a study that was done by Professor Stuart Webb, and the BBC wrote an article about this, that's saying that if you are a fluent native speaker, that means, for example, if you're coming from an English-speaking country, or someone who would call that they have native proficiency in English, they estimated that such a person would only know about 15,000 words or slightly more than that. But if you were trying to, if you were not a native English speaker, like you're coming from, say, for example, France or Spain or country like this, and you wanted to kind of have a conversation in English with an English speaker, Professor Webb was saying that, if you know around 800 to 1,000 most commonly used English words, you could understand around 75% of English without any challenge. That doesn't, so as you all can understand, so you don't need to really learn all of these 15,000 words. A small fraction of that still is enough for you to speak with someone who's speaking in English. If you compare English with other languages, there are, I think, so many languages that are spoken all over the world. You will find that statistics are roughly similar. Of course, there can be variations in terms of the way people write words, especially in maybe Chinese, Japanese, and so on and so forth. But the statistics are not significantly off. But of course, in order to be able to speak something like Mandarin, you will probably need to know a little bit more than 800 words, the equivalent of words, so that you can have a proper conversation. But I think you all get the idea. However, if you compare this, so if I go back to the last slide, so comparing the vocabulary, being able to express what you see on a day-to-day basis or something like that, you still have quite a lot of different words that you can use to have a productive conversation. Now, if you go to visualizing data, you don't have that much of choice. That is an interesting point here. So if you look at Microsoft's Office suite, Office suite is not the most impressive visualization tech that is available out there. But it happens to be the case that many people use things like Excel and PowerPoint, and they produce charts using these tools that are available. So a good majority of the people basically use these very basic tools that are available to us. And there are around 19 types of visualizations that you can do with Office. That's all. And even if you go a little bit more high-tech than Office, you find that Tableau has around 25 different kinds of charts, and Power BI, there's around 30. So roughly similar ballpark there between these kinds of tools. So they are like specialized tools which have been created for people to do visualizations. But again, that's all that they do. And if you go to a little bit more expressive frameworks such as D3, D3, according to Observable, Bostock's new initiative, that's the commercialization of D3, has closer to 60 different types of visualizations that you can use on Observable. So it's not much. So compared to speaking a language, if you were to explain something using a data visualization, you don't really have that much of choice. You can change colors, you can use creative animations and technique like that. But in terms of choice, people don't have that much of variety. So this leads to two challenges. One is the person trying to explain something has to use a limited set of tools to explain what they want. And also the second aspect, person trying to understand something needs to sometimes think beyond the box. Like you might be looking at a bar chart, but not every bar chart explains the same thing. You might have variants of the bar chart used to explain different things. And people also tend to creatively, embed more information into a well-known chart. sometimes not thinking about the recipient or the person reading or interpreting the chart, often leading to confusions. So the challenges are based on, like the simplicity of the language that we use to express visualization. So with that in mind, let's take a look at some of the examples of data comprehension in society. Data comprehension means the ability to understand or comprehend data. Okay. So one of the most well-known visual representations is the London's underground or rail network map. So of course, this was proposed many years ago, and now it has been recently improved in 2022 to include the Elizabeth line. If you can see, this is the latest map. Some of you may not have this at hand, but you can see the new line appearing over here. So for someone who knows London very well, you can very easily navigate this map, and you can understand, which combination of tube you need to take to go from A to B. But if you are a person who is visiting London for the very first time and you're presented with this, it can be slightly challenging. Maybe more challenging for some people than the others, but based on where they're trying to travel to. But this still presents a very complex problem in a very simplified way. Just imagine another representation which confirmed to like a geographical. So the stations interested on this map, you all may all be aware, don't correspond to exactly where a station is physically in at. This map has been conveniently redrawn that for people to understand, which kind of route they need to take, but it does not exactly explain which stations are closer to each other, which are like miles apart, and so on and so forth. You can't understand it from this, and the Thames does not flow in this kind of a weird geographic pattern. But if I were to ask you an interesting question, if you were to pick two stations, like for example, Oval to Oxford Circus, and explain to me how many different combinations were there in terms of the tube network that you can choose to go from A to B, I think an average person will be spending around 10-15 minutes trying to understand this, because there are numerous possibilities that are there. And it's not an easy question to answer. But still, it's a very useful tool for most people. To understand how visualizations are actually productive, Bedham and Elmquist, they did a study last year to explain that the approach that you take in terms of data visualization is very important. So they took the same data and they presented it in 3 different ways to an audience and asked them to rate their experience. Basically, the efficiency, how easy it was to use, did they really enjoy it, and so on and so forth. So contrary to popular belief, where people were interested in sort of overview visualizations, like for example, if you were trying to navigate something fairly complex on a very small screen, people were under the impression that if you have menus that can move away from the screen, you add it as and when you wanted, or the legend can be minimized or maximized depending on kind of tool that you're using, or you can use the phone swipe interfaces to load and unload various parts of visualization. People thought that it was a nice way of representing vast amount of information in a small amount of space. But turns out that people don't really like it. So this research specifically shows that compared to a large display, which obviously could display a large amount of information, you could kind of compact the same data and present it in a very similar way, and people would like that kind of a sometimes congested view than like a visualization which involved sort of like an overview. But you may realize, like if you, I also have, I think, a few examples from the BBC, for example, which uses the overview interface kind of a approach. It's the second approach that they have here is not very popular, but it goes against what people at least said in their survey. And then comes the requirement to consistently report things. Now, first of all, I explained the complexity problem with the network, and then next I explain the approach that people need to take in terms of choosing which kind of visualization approach that you need to take to present data. Third point is about understanding that you are telling sometimes a story, and you need to be consistent in your approach, especially when you are reporting things and you are explaining things, the changes over time. This is a map from Ukraine explaining based on from the BBC, based on the Institute for the Study of War, which studies the Russian-Ukraine war, which is happening these days. And you can see the map from the 27th of October compared against the map from the 3rd of October. They follow a very consistent pattern. Not only that, the same kind of approach is taken in other kinds of maps BBC has. So if you are a BBC the reader or viewer, you can very quickly understand something from this map, like which areas, for example, is Ukraine gaining control, or what kind of offensive Russia has over some time. You can see that, for example, the Russian forces are stagnating and Ukraine is sort of attacking back and then regaining their, like the various cities that they lost in the previous months. So this kind of a consistency is also very important. But despite all of that, right? Despite all of these kinds of well-known concepts, you all may think that the majority of the people who create these kinds of visualization should know these kinds of things. You find that people often make mistakes. So these are 3 examples that is from like an online form platform called JotForm, which did sort of an article along with Professor Ed Cook from the University of Richmond in US to explain. I think they gave examples of 5 of the worst visualizations that they could think of. These are 3 of them. So the first one over here on the left is from the Journal of Clinical Epidemiology, one of the very popular journals. As you can see, it has been running for many years. The author chose to use a 3D bar chart to an extent where you can see, if you look at especially the last, the 5th row, you cannot kind of even interpret what that really means, and the variation, it's not clear at all. So this looks cool in terms of a visualization, and 3D bar charts is one option that you can find in most visualization tools. But when you create a visualization using 3D bar charts, it's hardly understandable. So Professor Cook actually says that he can't understand why someone would ever want to use a 3D bar chart. It's an interesting point. I mean, most of you, some of you may not agree with this, but it's an interesting point to consider. Now, the second thing, example here, is not something like the 3D bar chart. It is just purely someone's choice. Someone thought that it was interesting to kind of paint the map of the US in a way that it explained how much of the kind of languages or rather the kind of population of the, in this specific case, that people, the evolution of people in US over time. So they are predicting by 2060 that the population diversity will even go much higher based on what it was in 1960. Now, Their statistics are really good here. The forecasting is also really good here. But the kind of chart that they have used to explain this does not make sense at all. For example, if you take a look at 2010, again, as Professor Cook points out here, there are Asians and also people from other backgrounds in the US, and that population has increased compared to 1960, but you cannot see it on this map simply because they used the wrong kind of approach to visualize something. So you cannot literally do something that you might think is nice in a visual to communicate data, because the person who is trying to interpret this information might not be able to. So this is again done by a news network that was popular at the time, but it's not easy for people to interpret. Now, the third visualization, Professor Cook himself could not understand what this is. This is coming from ESPN Cricinfo, a cricket website, which explains the amount of runs people have scored in a specific team, and the percentage of their score against the overall in that specific team. So you find, so for example, Williamson's coming from one team, and he scored about 1/3 of runs that were scored from that entire team. Now, if this chart did not have the title, and even if it had the title for someone who really does not understand cricket, you really can't understand what this means. And for example, using a pie chart for this really doesn't make sense. I mean, there is no value that it adds, and the confusion that it creates is far more significant. So just three examples, but you might wonder like why people do these things, and the other examples that I have later on are even more interesting. So next set of slides, I'm trying to also explain challenges that some people, like especially if you cannot hear, or if you cannot see, a certain amount of our population are people like this. You might find that when you go to read and write, especially, there are ways of like language just specifically targeting these segments of our population to help them read and write. Now, I'm not trying to tell that we need to create data visualizations to help them. Of course, according to the Equality Act, we as researchers have to think about this community as well, and how to communicate data to that. That is one whole segment that needs really good solutions. But also you can understand that you need to put a lot of effort in terms of communicating everything that you do, either via legislation or preference, so that a broad audience can understand what you're trying to say. Now, when it comes to spoken languages, of course, you find BSLSP, the interpreters, or you also find Braille, print, so that people who are blind can understand something. And also for people who have who find it hard to learn fast, Vigit is another language from the screen capture here is from the Sensory Trust, to help people like that understand and communicate. So we have approaches that are targeting these kinds of people. But if you take a look at data visualizations, something that is widely known is how to create data visualizations to help colorblind people not confuse line charts or bar charts and so on and so forth, for them to be able to interpret it. And there are color schemes and things like that that have been developed over time to help colorblind people. Beyond these color schemes, there are also a number of tools that you can actually use to validate what you develop. so that you will not be making any mistake in terms of how people would interpret your data. And why this is a requirement: around 8% of the global population of men are colorblind. If you are a woman, it's not as bad. But depending on, this is a genetic condition. So depending on which part of the world you are from, if you are, for example, if you are coming from Arabic countries, the problem can even be even worse. You can have more people who are colorblind, especially in them being unable to distinguish between red and green very easily. Now, with all that in mind, this is an extract from gov.uk. And mind you, there is something called the Colorblind Awareness, which is like a rights group which is fighting for the rights of colorblind people, according to the 2010 Equality Act. And even in the parliament, they have spoken very many times about how to represent, data, information, and things to help colorblind people not have a confusion when they're interpreting data. But now here we have the government's coronavirus dashboard explaining the vaccination. So basically the booster vaccination uptake. And I have two variants of the same chart. So if you have normal vision, you can see both very clearly. If you are colorblind, both of it, of course, will look similar, but you will understand the confusion still. If you take a look at, for example, people from 85 to 89 and people from who are above 90, you cannot really distinguish it. So I generated the right-hand version using software on my computer. So there are many simulators that you can use, but it's strange that people who are behind the government's coronavirus dashboard did not pay attention to this. So this is an example of things where people think might have, should have been very well thought through, but people often forget. And then also there are interesting biases and misleading statistics that are also accompanying advertising campaigns, marketing campaigns, and so on and so forth. Or sometimes maybe it was not something that was meant to be a part of a campaign for commercial advantage. Maybe it was done for the broader good of the society or whatever. But sometimes what you are trying to explain using statistics may not be what you say in your summary report. Sometimes this happens in news. You are speaking of one thing and supporting your claim with a set of statistics that claims another thing. This example from Colgate in 2007 is a advertising campaign that obviously they did for their benefit. They claim that 80% of dentists recommended Colgate as a toothpaste, but actually, and they supported this claim with some statistics based on a survey that they did. But in fact, the survey actually asked another question, very like almost the same thing, but in a it had a slight deviation from this point. They basically asked dentists to list several brands of toothpaste that they would recommend. And because Colgate was popular, most of the dentists would list them as one of the brands that they would recommend. But this does not really mean that 80% of dentists recommended Colgate as a toothpaste that people should use. But by doing this, they created a situation which gives them unfair advantage. So the Advertising Standards Authority basically concluded that the claim was misleading, and their advertising campaign was significantly criticized around 15 years ago. And this is one good example of using sort of misleading statistics and biases. So as you all can see, so it's not sometimes that people make mistakes unknowingly. Sometimes people make mistakes on purpose, maybe for commercial advantage. And another great example, especially with President Trump from the US pointing this out, is the rise of fake news. At Imperial, we actually have a set of researchers who are specifically studying fake news. And this example is coming from a website called dataprime.com. which takes two incidents from Fox News where they use the news to inflate reality, basically, which creates confusion among people, and also they can sort of provoke people in a specific way, especially when it comes to an election. They can sort of manipulate the audience to an extent where they would go and support certain kind of a candidate rather than another kind of a candidate based on what they try to promote here. So the first chart basically explains that the Christian American population is reducing, but they use, they have changed the y-axis here on this first chart to show that the reduction is very significant than what it actually is. And then you also find the news agency in 2012 explaining, the popularity of candidates. Now, if you adopt the percentages, it is clearly well beyond 100% here, but they use the pie chart so that they can very easily show that there are three candidates, and of course Palin was leading, but they have used the percentages to give an impression that all three candidates were popular, but then Palin had a significant majority. Now, they're trying to explain something else, but they use numbers and visualizations to kind of make people believe in something that is not real. And that explains some of the challenges that we have in terms of data visualization and data comprehension in society, but also some of the good things that people have done or studied over time. Now, we also study data comprehension in industry. So those examples were basically from society and like people speaking of various things in general. But when it comes to industry also, there is an expectation that you will know and be able to work with data and so on and so forth. But here, people are talking about something very specific to a specific domain, for example. Like if you take the representation of data in the industry, organizations rely on a lot of BI and analytics tools. So these are just some of the tools. You can see that there's quite a diversity here. This is Gartner's quadrants, basically the Magic Quadrant explaining which tools are popular and which are the upcoming and so on and so forth. You can ignore that fact, but I use this diagram to show you that there are many tools, many options that are available. And this is only just a subset of the grand list of things, right? So one of the expectations as a person who is working in a reporting team or a data analyst in a company is that they understand lots of these kinds of tools, and then they're able to correlate data across different tools, or they're able to switch from one tool to another. So when someone in the industry speaks that you have a really good ability to work with data, that means you have a really good ability to work with a number of tools. These tools don't work in the same way, mind you. There are various kinds of approaches that they need to take. Sometimes they have domain-specific languages that you need to know, different kinds of interfaces that you need to work with. But there is this expectation that you can work with these kinds of tools. And it is not sometimes experts or data scientists or data analysts. There is also sometimes expectation that the ordinary person of a certain level of seniority would also be able to use some of these tools to explain, some of the metrics with regard to their data. So industry has this set mindset and expectations that they have when it comes to being able to work with data. And then also, at least during the last 5 to 10 years, we see a growing interest in data stories. Why data stories? Because as I spoke earlier, there are only maybe 20, 30 different combinations of visualizations that you can effectively use. If so, how to explain your point? or how to emphasize on certain things. So data stories, this is from a data story, platform sort of vendor that they have done this kind of thing just to show, the Atlantic and Gulf Coast shark incidents. You can ignore that point. But if you take a look at this visualization, you can see that they are using different kinds of charts and different kinds of representations in a single consistent, graphic to make a certain point. And you can see, especially in this part of the US, you can see that there is a lot of incidents, lots of sharks in this area, whereas the rest of the coast does not have the same kind of impact. And then you also find, if you are in a specific segment, like for instance, if you are in sales or you are in marketing, you also need to be able to interpret certain things in a specific way. This is something called a sales funnel that I have here from, I have extracted this from a sales and marketing platform called HubSpot. So if you were to explain what you are doing in terms of sales and marketing, you need to kind of know the funnel. You need to be able to present your reports or analytics in this kind of format. Otherwise, the other people cannot understand what you mean. So there are like these kinds of terminology as well that has evolved in the industry. So looking at the skill set that you require to interpret or work with data, or looking at the mistakes that you shouldn't do previously when it came to data for society, industry expects people to also know a lot about the domain or the specific segment which you are in when it comes to interpreting or presenting data. And then also you might need to report certain things from the industry to the general public. And this is an example of that. This is from the Royal Mail Group's priorities for sustainability. You might want to conform to some sort of a standard, or there may be no other way that you could explain it in a consistent way. So the expectation, obviously, from the industry is like a specialization of what you can find in society. So you often find both of these requirements being emphasized especially when we teach people about how to build effective visualizations. It's not just about doing the right thing. It's also about presenting information in a way that everybody else understands. So this is also very important to consider. Okay, so all of that gave you, I think, probably got you thinking in different ways. I would like to sum that up in terms of the effectiveness of data visualizations. And that is one thing that we studied a lot at Imperial. So it is useful to have a data observatory because we can engage with lots of people at the same time. And also there are lots of possibilities of explaining the same thing. It's a large screen by all. It's immersive as well. So you can have a conversation without having a person stray away and lose focus. You can get them to specifically, like an environment like this gives you less option to be distracted. Of course, you can be distracted and focusing on another part of the screen. That's something else. But it generally helps people hone in on a specific kind of piece of information in this kind of environment. But it also gave us the ability through gaze tracking and attention tracking and so on and so forth to able to understand what people are actually doing in the observatory and how focused they were, how interested they were in a specific kind of data visualization. So we could kind of study examples from visualizations that were built for the general public and also visualizations that were industry specific and understand how people reacted to these things. And based on these things, of course, through consultancy and so on and so forth, we could teach people, you ought to probably do this than, following another kind of an approach. So that's something we actually did at Imperial. But we also wanted to have a scientific basis in terms of studying how people react to data visualization. So one approach that we have taken is to use EEG. So you have like your various sensors connected to your brain, so to understand the reactions of the brain, and how you would interpret these kinds of like an image, or how you would react to an advertisement, whether you would recognize a popular brand instantly, and so on and so forth. So these kinds of studies also helped us actually, rather than kind of using surveys and these kinds of approaches, we actually could get sort of an understanding of real emotions and human behavior based on what they actually saw. So it's more scientific in this sense. Of course, it's difficult for us to kind of replicate these experiments on almost everything, but these were some sort of a basis to strongly support our claims. And then obviously we have used the space also to communicate the research that we do at Imperial. Also, there are industry partners who use the space to communicate their research. And here you find a professor from the Leonardo Center of Imperial explaining sustainability. Coincidentally, I built this entire visualization for him. So it's interesting to see how people use this space, especially to conduct seminars, to run workshops, and so on and so forth. But also, this is a living and breathing environment where we can actually study people's reactions to data visualization. So this led us to come up with 5 key aspects of creating data visualizations, or what you would need to focus when you are designing a data visualization. The first and most important aspect to us was simplicity. So there is, of course, you might have done a great experiment, you might have lots of data, you might want to make a significant point, you might want to put lots of information or pack your presentation with lots of information so that someone could understand the point better. But it turns out that we all have a very short attention span. And then you will, like most of us, will be focused on certain aspects of a data visualization. So if you could focus on just those aspects, that is the main point that you're getting across. And if you don't overcrowd your data visualization with like additional elements at any point in time, that helps the audience interpret the data visualization more effectively. And the second part of it is also connected. This is interactivity. Now, you might be having some sort of a, like a data visualization which is simplistic or very beautifully created and so on and so forth. But rather than making it passive, where someone just looks at it and tries to understand it, if you make it interactive and let them interact with it, make changes to it, and try to understand how this changes, how the visualization reacts to these changes, they tend to be more engaged. The interface not only helps people look at different dimensions or perspectives of the data, it also helps them be more engaged with visualization itself. So one of the studies that we did, actually we proved a point where we could have designed the data visualization in a non-interactive way, but we added some level of interactivity to this, very basic. But that meant our audience was more engaged with the data visualization, and they understood the point better than just being passive. So interactivity also, even though it can be very minimum, help people understand data visualizations better. Then third and fourth points, you understand the accuracy and the clarity of what you are trying to present is also very important. Accuracy is the basis of how well people will trust what they see. So sometimes you might find an audience, and if they see something inaccurate, they may know something more than what you know, or maybe there is an obvious mistake, can be a spelling mistake or something. You lose the kind of legitimacy that you have in terms of what you're presenting. And the clarity, of course, is also very important to avoid an audience getting confused. Interestingly, aesthetics and visual appeal, which many people focus on, is like the last topic. And of course, that is very important. You might want to make something look nice so that people try to talk more about this visualization or fall in love with it. But that is perhaps the least most important aspect here when it comes to designing an effective data visualization. So I just wanted to take this example from Gapminder tools. Gapminder again explains the sustainability or initiatives to make deal with challenges that UN has set forth in terms of sustainability. The Gapminder tools website is a really good example of how you can build a very effective data visualization. It has all of these 5 principles that we spoke of. It is very easy to use. It's targeting the general public. There's a lot of interactivity built into it. They are using data from very well-known sources and so on and so forth. There's a lot of accuracy. The clarity is really good. And also they use nice color schemes and presentation techniques and then interactive, animations and things like that to make whatever they present very attractive. So this brings us to the point of the role of the person developing visualization. So of course, the Gapminder tools, visualization were built by experts.
Seneca, sorry to interrupt. We've got about just 5 minutes left, and I don't know if you want to give anyone any time for questions. Just to.
This is the last slide.
Oh, okay. Right. Sorry about that. Good. Just so you know. Brilliant.
Yeah. So. So this brings us to a very interesting point in terms of building visualizations and so on and so forth. So the role of the person developing the visualization is very important here. Now, at no point we felt that the role of the person interpreting a visualization was as important as the role of the person developing a visualization in our studies. So all of these techniques, paying attention to detail, following those best practices, taking examples from well-known visualizations and so on and so forth were all important in terms of developing data visualization. So I'll stop with that and I'll let you ask some questions. Thanks, Nick, for that reminder. But yeah, I'm probably 1 minute late or so from my expectations. But yeah. So anyone wants to ask questions, I'm more than happy to take them.
Now I hope someone has a question. Okay, well, they're thinking.
Nick, I'll start the ball rolling. It's Roy Ruddle.
Brilliant, go for it.
Thanks for your talk, Sunarka. Very, very interesting. As somebody else who's done a lot of work with big display walls, in our case, come up with a killer application in cancer diagnosis, combining visualization with cancer diagnosis. I'd be very interested in what genuine sort of types of insight users were getting with your fantastic looking cylindrical display wall that they're not capable of getting, say, with what I would call an ordinary desktop display, like say a 4K display sitting on a desktop.
That's a really good question. So one of the objectives of getting people into, we call this like a cave sort of an environment, is the ability to have like a collaborative conversation about what people actually see, or getting people to sort of interact with each other when they are observing vision. Now, of course, they can get people into sort of a boardroom and present something like this on a screen, and they would be able to collaboratively discuss some sort of a data set or something like that. That is a common argument that people make, like, why would you need that kind of an immersive environment compared to like a corporate boardroom? But the layout of the cave, the cylindrical layout, and also the fact that you got visualizations all around you, tend to get people to be more focused in terms of what they're actually looking at. And the audience also does not stray away, though you may think that they have lots of options with the large screen to go and look at something else when someone is talking. That rarely happens. But when you are seated on a boardroom table with a bunch of people trying to collaborate, there is ample room where you will lose focus in terms of what you're looking at, and start having other thoughts, or taking the conversation in some other way, and the visualization no longer becomes the most important thing. So this was the main, I think, the gain that we had, apart from the environment being impressive when it comes to working or presenting data. But there were like other gains as well, like for example, the space helped us sort of display animated things like like WebGL sort of, and sorry, not WebGL, GL sort of animations and so on and so forth, which we could not fit in a smaller screen, especially when you want things to be interactive, or large images, gigapixel images, and so on and so forth. It was useful for that kind of thing. But I think the main gain was to get people to collaborate more in this kind of an environment. It has pros and cons, of course.
Thank you.
Yeah, go for it. Kai.
So, and my question is kind of maybe two parts. So I think it was mentioned in the talk about the data literacy, and also to me is something more like visualization literacy. So data literacy is more like people understanding some information about data. For example, they understand the difference between, say, median and mean. And the visualization literacy will be, say, they understand, say, how bar charts or scatter plot works. So I think there might be some overlap between the two. And what, in your view, how do you treat this? Are they kind of similar, or maybe visualization literacy should be considered as part of the data literacy, and so on and so forth? And
that's
then,
a really good question.
Yeah.
Sorry, go ahead.
No, yeah, that's my question. Yeah.
That's a really good question again. So you are right to some extent, but there is a significant overlap when it comes to data literacy. And if you want to subsegment it as visualization literacy, to an extent where people refer to visualization literacy as data literacy in many cases. So being able to interpret data, of course, a table is one way of visualizing data in some contexts. But you can also present data in a raw format, but it is hardly understandable by the recipient. So there are, of course, if you are not using a visualization, if you are presenting data in a non-visual format, yes, there is possibility, but that does not kind of give people the ability to sort of understand that kind of a data set better. So there are some people, Kai, who thinks that this needs to be like visualization literacy needs to be spoken of as a separate topic, and they even want it to be thought of like a significant area of focus compared to like people understanding, the whole processing aspects of data and so on and so forth. Likewise, but at least based on published research so far, what we find is that when people speak of data literacy, they mean the literacy of the whole thing. And this is where I think the role of the visualization designer is also very important, because the visualization designer also though may not be involved in the processing of the data or the collection of the data or the other stages before a visualization is developed, they have to have a really good understanding about the source and also the workflow that was used to come up with whatever the summary results that they are presenting. Because at the end of the day, the person creating the visualization is sort of the interface between a data set that someone collected and the information someone is trying to get out of it. So that is where I think many people speak of data literacy as a single topic, because you cannot really segment these things and think of them or optimize them independently. You cannot just optimize the visualization without considering the earlier stages of data processing. That is the way I would explain it.
Yeah, thank you.
Cool. Excellent. Thank you very much. I won't ask too many more questions. I'll have to grab you another time. Thank you all for coming, and those of you still here staying. Thank you for that excellent overview and insight that you've got there. I'm interested to know more about EEG, but I'll ask you another time.
Sure.
And thanks again.